Hi team, good evening. Our topic is pneumonia detection using machine learning algorithm. My team members are Lasitha, Thilakarathna and me. Firstly, I brief introduction about this topic. Pneumonia continues to be several global health challenges, particularly affecting vulnerable groups like infants, older adults, and individuals with an immune system. The high morbidity and mortality rates associated with pneumonia highlight the critical needs for efficient diagnostic solutions. Traditional diagnostic methods such as chest X-ray and clinic evaluation are also valuable, facing significant barriers. These include limitation access, high cost, and need to skill medical professionals that can prevent a timely and accurate diagnosis. In response to these challenges, machine learning now offers to transform approach to pneumonia detection. By harness of the power of the algorithm, we can analyze medical images at scale, providing accurate and time diagnosis that can critical for patient management and improvement outcome. This integration of technology is paving the way more accessible and efficient healthcare solution, helping to address the gaps in the traditional diagnostic practice. Over to Lasita to continue it.
Yeah. Hi, I'm Lasitha. Our problem is the serious health issue of pneumonia, highlighting its widespread impact, particularly on vulnerable populations such as children, the elderly, and those with weakened immune systems. Pneumonia can lead to significant illness and death, making prompt and accurate diagnosis essential for effective treatment and better patient outcomes. However, conventional diagnosis methods like physical exams and lab tests often take a long time and may not always be readily available, which can hinder timely care. Exploring automated detection systems that utilize machine learning algorithms to classify pneumonia from chest X-ray images. This approach aims to enhance diagnosis efficiency and accuracy, making it more feasible for practical use in healthcare settings. By leveraging machine learning, the goal is to provide quicker and more reliable diagnosis, ultimately improving patient care in the real world. Okay, Gyan, go to next slide. Our the dataset structures from Kaggle consists of just X-ray images labeled as either pneumonia or healthy normal. It contains a total of 5,216 images with 3,875 labeled as pneumonia and 1,341 labeled as normal, providing a reasonably balanced distribution for training and evaluation. The dataset is structured into two categories, pneumonia and normal, and all images are in JPEG format to ensure consistency across the models. The images were preprocessed by resizing them to a standard size of 128 pixels and converting them to RGB format, even though some might originally be grayscale. This preprocessing step facilitates better input handling across various algorithms and improves training performance. Over to you, Gyan.
Okay, Lasita. Okay, then Lasa, can you see my code screen?
Yes, I can see your screen.
Okay, thank you. Actually, the first time we take to supervised learning type as SVM. SVM. Firstly, we doing uh, Installation and import required library. The first step, install and import an essential library. Pandas, NumPy and Matplotlib are used for data manipulation and array operation and floating images respectively or toys, or also interactive with file system to access image directly. Also PIL, Python imaging library used for resizing and converting images while training test split from scikit-learn to split data into train and testing check. So CV2, it's open CV, is important. It is not actively used in code snippet. So firstly, this is the internet. After then, these are my libraries. Then I come load file, load the data. Load data, there are two types: normal files and pneumonia files. So using the os.list function to code load the names of image file from normal and pneumonia direction. This step helps to confirm that files and correctly read from the dataset. The code prints the first five and last five files name from each folder and verify the data loading. So these are the output of the five JPGs and first five and last five in normal, and these are the pneumonia first five images and last five images. So next I move to label part. In label part, there are the numbers of images can categorize into counting using length. Provide inside data set distributing. So labels are generated. Zeros are normal images and one are pneumonia images. These labels are stored in list and contact from single label list. Printing a same sample of this label ensure that they are correctly created and aligned with images. So these we are normal labels and pneumonia labels. Then we are get and normals. Then I come to visualize a sample image of pneumonia and normal image. So sample image from each category are displayed using Matplotlib. This visual check ensure that the images are read correctly from dataset. It also gives a sense of how normal and pneumonia affected lungs look in the X-ray scan, which is essential for later analysis. This is a normal image of the, and this is a pneumonia image. So then we move to image processing part to this model to insert the images. So loading and processing image part. In the code load to all image from both categories, resize them to 128 multiplied 128 pixel, convert them to RGB format, and store them in as a NumPy array in the data list. Then pre-processing step ensure that all images are uniform in size and performance, making them suitable for input into machine learning models. So these image processing after that we are doing to converting data and labels into num array. So data and labels is list converted to NumPy array to enable efficient operation required for model training. Printing the shape of this array verify that the data contains all the expected numbers of images their dimensions. This step ensure that dataset is correctly prepared for further processing. So convert after that we check the type of num array in the data set in labels. Then we come to train and test split type. So in using train underscore test underscore split, the data set is split into 80 percentage and training and 20 percentage testing subset. This separate is essential to ensure that machine learning and model learning patterns from the training data and is evaluated on unseen test data to prevent overfilling. After that, we do scale the data set. So scale data is scale x underscore train and x underscore test. So the pixel values of the images are divided into 2555 to scale them to range of between 0 and 1 normalization, and the data is way to ensure that model convert faster during training by preventing large gradient update and making it essential for algorithm to learn. Then we display the scale data example. This this doing an array. So the code print first image of the scale dataset to verify normalization process. Checking of the pixel values ensure that data has been correctly scaled and confirms that the reposing step have successfully applied. So okay, then we Come to flattening and training dataset part. The flattening dataset. The code being by flattening scale training and testing dataset using. So this operation transform to 2D images into 1D array, where each images become single row into 2D array. The minus one augmented automatical calculation update number of columns based on the total of the pixel on each members. The flattening is necessary because the support vector machine SVM model expecting to data into 2D array format where each row represents sample and each column represents further. So after then we can show that flat train data shapes and test data shapes we can get output. Then we come to train on SVM model. So mm, in SVM model. So in SVM model we can it's a supervised learning model. So in this SVM model, firstly we install the SVM model. So SVM model install svm.svc. This lines set up to line a kernel SVM with regulation parameter C to 10, which helps to control overfitting. So the random state parameter is set to ensure reproductivity of the result. By using line kernel, the model will classify and data by creating line decision boundary. So okay, then built in the SVM model to train data. The SVM model is trained to flattening data use SVM model.fit, the function used to call flattened images as input and corresponding labels to fit models. Allow the test learn pattern that distribute between normal and pneumonia image. So now make prediction part on the test data. The SVM model take two labels for the flattered test data using this step applied to learning patterns of training based on released dataset, generating prediction integrate which each image is classification as a normal pneumonia. So this is a prediction part. Then I come to evaluation of this model. So in this part, the accuracy of model calculate using accuracy, which compare with the predict labels against the true labels. The accuracy is the printed with providing these functions and quality measures of the model fraud. So also create a generating classification report. In this code generator classification report is printed. Also this report provided detailed metrics such as prediction, recall and if screw and both classes normal and pneumonia, offering insight into models performed beyond some simple accuracy. Then create a confusion matrix. The confusion matrix is a computer using to visualize the performance of the classification model. The confusion matrix is printed using printed it's following by itself. The matrix display are true positive, true negative, false positive and false negative counts which helps to identify where the model is making error. So then we come to plot confuse matrix. This is the confuse matrix picture. The confuse matrix a visualization using plot plt.im show, creating a color and color code and represent of the matrix, axis label and ticks added to clarity, indicating prediction and true labels. As loop with PLD text is using the annotation with matrix count of each cell and enhancing visualization by making number of visual on the plot. Then display the confused matrix plot. This confused matrix plot is a display using plot show, providing visual assemblet of the model classification form. The blue color map is given clear indication how many predictions for very interacted. Then plotting model accuracy. Finally, we Bachar create a visualization model's accuracy using then also y-axis is set to range to 1 to 0 with and title added, then visualization percent accuracy quickly inside the perform. So this is display accuracy plot of this one. Uh, then also finally I model save and get check a prediction of the is pneumonia normal. Then I take a pneumonia normal and normal and pneumonia me. Then they currently get clearly output, and also this model accuracy is 0.9.5. So it's a CA model is a good thing for to this to pneumonia reaction. Over to Lasitha too.
Checking on. Can you see my screen?
Yeah, Lasitha. No, can see.
Here's my installed libraries. Uh, Eagle, Matplotlib, Seaborn, TensorFlow, Keras, and Learn. Uh, I do this using CNN algorithm. Yeah, I mounted this to the Google Drive. Here I upload my JSON file and to the Kaggle. I download the dataset from Kaggle. Here I extract the data to the Google Drive. Here I import the necessary libraries, NumPy, Matplotlib for data manipulation and visualization, TensorFlow and Keras, for building and training the CNN model, Image data generator for data augmentation, which increases data diversity by randomly alternating images. Here I define the paths for training, testing, and validation the data. This path should point to directories containing subfolders for each class label. Here I display some example images. I load few sample images from each class. Here data pre-processing, image pre-processing, and augmentation. Here I load the images. Here I define the CNN model. The model uses a sequential approach, stacking layers in order on a 2D layers, extracts features which filters the 264 and 128 size 3 by 3. Each layer detects patterns at increasing levels of complexity. Max pool in 2D reduces the size of features, keeping only the most important parts, reducing computational needs. Pattern converts 2D features mapped into a 1D array, connecting to dense layers. Dropout randomly drops 50% of neutrons to prevent overfitting. The final dense layer with a sigmoid activation function output probability score or binary calculation and 0 or 1. Here I compile the model. Uh, Optimizer Adam is a popular choice, combining the advantages of other optimizers for faster convergence. Loss function binary correspondency is used for binary classification. Metrics accuracy is used to evaluate performance on the training and test data. AI train the model. AI evaluate the model. AI generate the predictions. In summary, these notebooks systematically loads and preprocess X-ray images, builds a CNN model to classify these images, train the model, and evaluate its performance. The process involves the deep learning concept, including convolutional layers, pooling, dropout, and data augmentation, which are instrumental in achieving accurate medical image classification. Over to you, Gyan.
Okay, Lasitha. So, then we used to in second part of unsupervised learning. In unsupervised learning, I get K-means algorithm. So in K-means algorithm, firstly I installation and import library in pandas, NumPy, Matplotlib, OpenC, Python, Headlines, sklearn, and joblib. And these are library used for task data manufacturing. So you used to install that libraries. Then I go to file path to dataset. Then I show the first five of normal images and last five images and pneumonia first five images and last five images. So after then checking number of images for how many images in this that one. Also creating labels of the images. So zero is zero and one. Zero is normal images and one is pneumonia images. So this is the sample of these images. After then I this pre-processing for images into RGB. After then these images are converted to NumPy arrays. So the images data and labels are converted to NumPy arrays to effective computation. After then I apply to K-means algorithm. So K-means using cluster image in two groups, so normal and pneumonia. The number of images in each cluster is printed and the cluster label for first few images show for this is one. Then visualization with cluster with images. The first four images displaying their cluster and label to show how to K-means cluster separate into images. So this is the first four images in clustering images. After that, the visualization some clustering images. Then visualize creating a data frame for clustering result. The data frame is creating flatter image data with additional column with cluster label, random values and rate for BMI and flat percentage column to demonstrate scatter to propagation. Finally, visualization cluster is using C-band, like scatter plot, create a visualization BMI and first percentage which color represent different cluster. So this is the k-means clustering image. And also the count plot the number of images are each clustering giving overview of the clustering. This is the distribute of images of across clustering. The clustering 0 is a red color and blue is cluster 1 is has a blue color. So that is the unsupervised learning algorithm. Over to Lasitha.
Can you see my screen?
Yeah, Lasitha.
Okay. I do this using anomaly detection algorithm. Anomaly detection for pneumonia detection using an unsupervised encode algorithm. Notebook implements an anomaly detection method using an unsupervised learning approach with an autoencoder. It aims to identify pneumonia cases as anomalies based on reconstruction errors using healthy lung X-rays as the baseline for normalcy. These are my installed libraries: TensorFlow, NumPy, Matplotlib, and scikit-learn. Here I import the libraries. Uh, the code likely start by importing essential libraries such as NumPy, Pandas, Matplotlib, and Seaborn for data manipulation and visualization. TensorFlow areas must be imported to build the autoencoder model and scikit-learn for performance metrics. Here I mounted to the Google Drive, and here I connect this to the Kaggle dataset. Here I load the export dataset. This section loads the Chest X-ray images dataset, which could be stored locally or hosted online. The dataset may contain normal and pneumonia affected chest X-rays to train the model to differentiate between them. Image preprocessing libraries like PIL or OpenCV Python may be used here to preprocess images. Data preprocessing. Images are sized to fixed dimension, example 128, 128, 256 pixel, and normalized pixels will scale between 0 and 1. Images may be converted to grayscale if they aren't already. Data augmentation must be applied to increase the dataset diversity. Example, rotation flipping. It ran the autoencoder. Here, evaluate the reconstruction errors. The dataset is split into training, validation, and testing sets. Typically, only normal images are used for training the autoencoder, as it needs to learn a normal representation of chest X-rays. An autoencoder is a type of neural network used to learn efficient representations of data. The architecture consists of two main parts. Encoder converts the input image into lower dimension representation. Latent space. Decoder attempts to reconstruct original image from this latent space. The model is designed to minimize the reconstruction error, the difference between the input and reconstruction output. Some are performance metrics and visualizations. my accuracy. The visualization, reconstruction examples and tests may be visualized to understand model performance. This could include plotting original and reconstruct images for the distribution of reconstruction errors for normal and pneumonia cases. What do you, yeah?
Okay, Lasitha. So we finally get reinforced learning. We selected the Q learning algorithm. So in this algorithm, firstly we install package and import modules. Uh, so in this algorithm, normally we install the libraries and loading data sets. It's a normal and pneumonia data, and when they show the normal and pneumonia data set of images RGB. So then we pre-processing the images and labels. Uh, so after that, we split the data set into test training and testing due to 80 to 20 ratio through train underscore test underscore split from skin. It brings shape training data set split. After then, I installation the Q learning compounds. So give define the Q table, set hyper parameters alpha, gamma, epicial, and epicos. So after that, I used to train the Q model. So it tried to order to train data from a specific number of epicos for each images and action selected either randomly on the based on the Q table. So reward mechanism one +1 and -1. So update the Q tables with Q learning formula after each step. Track the store average revoking accuracy of the epoch. In this epoch, we can add it to this adding in the 100. We can add 1000 or like to model of training. So this is a model is training is steps 100 types it's training. So get accuracy 0.6. It's a good accuracy. After that, I make a prediction. Make a prediction test data for each the model select best action based on trained Q table. Compute accuracy of prediction testable using accuracy score. So this is a classification report, a prediction recall. If one is can support the 0 and 1. So then plot the accuracy of Pico. This accuracy may vary rewards of Pico. So and this is average reward of rewards of over Picos. Then I get a plot of contribute matrix and then get a Q value heat mapping what we show that. Then finally we get a model save and the model load and check the image. The image is predicates a normal image. So actually these SCM and supervised learning model and reinforced model are good for to model training and get accurate predictions. So that's all explain about the supervised learning types and unsupervised learning and reinforced algorithm. Thanks for watching a video.